Okay, we're still talking about the normal model. Check out the latest announcement here. I posted solutions to this normal model extra worksheet that I had posted here. Well, you don't have to do this. It's here if you want to play around. And I had the solutions. I went ahead and posted them. They were already here, but I made an announcement about them. And then we'll go through them today. Remember, you really got to get chapter 5 down. It is the most important chapter in the class, and you're gonna have to have a graphing calculator. Like there are old school ways. When I took this class way back when, we had to use z-tables. I'm not even going to teach you how to use z-tables because everybody's got a graphing calculator now. And when we get to the later stuff, hypothesis tests and confidence intervals, there's really just no way to do t-tests or t-intervals using an old piece of paper table anymore. They're too restrictive. And we've got all this fancy software out there, including your graphic calculator. So that's the way I'm going to show you how to do that stuff. So since it's absolutely required for the last half of the class, you might as well make it required for the whole class. So chapter 5, we're using the calculator. That's the point I'm making right now. We have our test coming up soon. I just want to point that out. I'm loading the calendar here. I remember on the test, you can use anything that's in the Canvas course. You can't use anything that's not in the course. All right, it's an open note test. Practice test 1 is due on the 1st. You have to complete the entire thing. If you skip anything, you get a 0. And test 1 then will be due by the 5th. It'll be open for a few days. And that, like we looked last time, I don't remember what the time limit on it is. 2 hours, plenty of time. All right, let's take a look at this worksheet. So this was our setup here. We are told that Honda Civics follow a normal distribution in terms of their fuel efficiency. I made these numbers up, by the way. Don't go out and buy a Civic based on what I'm writing here. They do get good gas mileage, though. But we're told here they follow a normal model with mean 32.1 miles per gallon and population standard deviation 1.4 miles per gallon. First question is, okay, what percent of Civics get more than 32.1? So just think about it for a second. Like before we go through all the math, our average is 32.1. Normal distributions are perfectly symmetric. Half the population's above average, half are below. The mean is the median. So I don't even have to do any work here. The answer is 32, or the answer is 50%. But we can work it out and see that. So same 3 steps we always go through. We draw our picture. We draw a normal model. Right in the middle is the mean, mu, 32 point, oh, I wrote that wrong. I should say 32.1. Sorry, that's a typo there. I should say 32.1. Did I do that on every one of these? I did. Look at this. I wrote this document up a few years ago. I'm literally just looking at it now. You know what we're going to do? We're going to change that right there to say 31.2. Because that's the number I used in all these problems. That's so funny. Okay, so let's fix these. 31.2. Okay, so we draw our picture. Right in the middle is our mean, 31.2. We shade what it is we're asked about. We want to be more than 31.2. So I shade from the same spot over. I can clearly see I've shaded half the picture, but let's go through the steps. Let's find our z-score. Z-score is the one you want minus the one in the middle of the picture, the mean, divided by your standard deviation. So the question asked me for 31.2 minus the mean, the population mean, divided by the standard deviation. So you type that in your calculator and you get a z-score of 0. Z-score is not your final answer. Unless the question says find and interpret the z-score, you're not done. Z-score is not a percentage. That just means that a car that gets 31.2 miles per gallon is 0 standard deviations away from the mean. Now we get out our calculator and we need normal CDF. Okay, so we want to go here into distributions. So second vars down to number 2. We're never going to use number 1. I want to put in my lowest z-score that I shaded up to my biggest z-score. It's always smallest to largest. So the smallest z-score I used was right here, z equals 0. I'm going to write that underneath there. Z equals 0. That was right here. How far up does this go? It goes to infinity. Up here is really, because this goes on forever, up here is z equals infinity, but we can't type infinity in the calculator, so we just type a really big number. So I'm going from 0 to, I could put 1,000,000 if I wanted. I could just put any big number. But how big is big enough? Honestly, 10 is probably big enough. 10 standard deviations above the mean is gigantic. But what I like to use here is 99 because that kind of looks like infinity. Leave these 2 alone. Don't change those 2. And hit enter. And that's rounded off. That's 50%. So 50% of civics, remember word problems have word answers. 50% of civics would get more than 31.2 miles per gallon. Hey, what about B? What percent get less than 28.7? So we're going to play the same game. We're going to draw our picture. Right in the middle is the population mean, 31.2. 28.7 is way down here. That 28 is less than 31. And the question says, I'm shading below here because it says less than. So I've shaded everything below that. So I just want to figure out this little area here. I want you to draw these out because you can look at the picture and think about your answer. If I end up getting an answer like 85%, I can look at my picture and go, well, that doesn't make any sense. I clearly didn't shade 85% of this curve. I'm going to get a little small number. I just shaded this little tail here. So we find our z-score. The z-score is the one you want, the one in the question, minus the mean divided by the standard deviation. And I get negative 1.79. Check that on your own. Plug that in your calculator. Check it. Make sure you know how to find the z-score there. We're not done. Z-score is not your final answer, unless the question says find the z-score. So what does that z-score mean? So I wrote a little note here. That means that that car that gets 28 miles per gallon is 1.79 standard deviations below the mean. How do I know it's below the mean? How do I know this car right here is less than average? Well, first off, it's smaller. 28 is a smaller number. Secondly, you got a negative z-score. Negative z-scores are below the mean. Positives are above, negatives are below. Okay, but we haven't answered the question. That was just like a little side note there. We need to type this in our calculator. Smallest to largest. What's the smallest number all the way down here? Negative infinity up to negative 174. So I get my calculator. Second distribution, number 2. Negative 99. Remember, don't type that button. That's the minus button. Negative 99 to negative 1.79. Leave these two alone. Again, I know there are shortcuts you can use, but like on tests, I'm going to ask you for z-scores anyways. You're going to go through this process anyways. You might as well do it this way. There's our answer. And that answer makes sense. It's like 3%. Like I'm pretty far away from the mean here. I expect a small number. So 3.7% of civics get less than 28.7. What if I had typed this the wrong way? What if I had typed, because it's a common mistake, people will maybe do negative 1.79 to infinity. So on the graph, that would be here and above. That would be like shading all of this. Well, look at this answer. I get like 96%. See, this is why we draw the picture. If I get that answer, I look back at my picture and go, oh crap, I messed up something. That can't be right. Something else I want to point out. What if we had a really big z-score? What if we got a z-score of 12? So what if we had like negative 99 to negative 12? So I had a z-score of negative 12. That's a gigantic z-score. I may have gone too far there. Look, the calculator, that number, that probability is so small that the calculator said 0. It's actually not 0. Let's go a little bit bigger. What if we had negative 8? My tolerance is not set where I want it. I'm trying to show you something. Let's go negative 6. Okay, good. That'll work. Remember, what the normal CDF spits out is probability. You can't have a probability bigger than 1. So what we're looking at here is you had something that was 6 standard deviations below the mean. And we want to find the probability of that happening. There's no, first off, that's a gigantic z-score. Obviously, we're not going to get a big number. We did not get 900%. We definitely didn't get 9%. Look right here on the calculator. That's scientific notation. That's 9.9 times 10 to the negative 10th power. So that's 9 zeros, 99. It's a very, very small probability. You always got to be on the lookout for that. You'll never get a negative answer. You'll never get an answer bigger than 1. Okay, let's do the next problem. I don't know if I'm going to go through all of these, but I'll do a few. What about more than 29 miles per gallon? So we draw our picture. Right in the middle is the mean. 29, that's less than 31, so it lives down here. And the question said more than 29, so I shade everything. I can see here that I've shaded more than 50%. I'm expecting an answer, I don't know, 60%, 70, something like that, more than 50. I draw the picture. Find the z-score, the one you want, minus the one in the middle over the standard deviation. I got a negative z-score because 29 is smaller than 31. Normal CDF, smallest to largest. Smallest z-score that you shaded to the biggest z-score. And we got like 94%. Okay, what if we want to go between two values? I guess I am going to do most of these. We draw our picture. I want to be between 30 and 33. Draw the picture, find both z-scores. Notice 30 has a negative z-score because he's less than the mean. 33 has a positive z-score, he's bigger than the mean. Never add z-scores. Z-scores are not percentages. Then we do normal CDF, smallest to largest. Watch what happens if I type this in backwards. If I accidentally type that one and then that one. So 1.29 to negative 0.86. On my calculator, it actually gives me the right number. It just makes it negative. Some calculators, some of the older ones, it just confuses the calculator. And it tells you an error. You always go smaller to larger. You're never going to have a negative answer. Like, that's just wrong. You can't have negative probability. It's because it was typed backwards. Okay. Next question said, find and interpret the 99th percentile. I love these and interpret questions. That means, write words. What does that mean? The 99th percentile. So we draw our picture. The 99th percentile will have 99% of civics below it. So I'm looking for a guy up here where this area below him is 0.99. So I use a different button on the calculator here. We're working backwards. They gave me the percentage. I want to work backwards and find the car, the X. So that's a different button on the calculator. That's inverse norm. That's number 3. The only ones of these we're going to use are 2 and 3. So the area below, you could do it either way. You could do area above by doing right. I can't think of a time we'll ever use center. I always just use left. Leave that on left and put the area below the guy you're looking for. So that was 0.99. You got to put it in as a decimal. Leave those two alone. .33. That's my z-score. Again, I know there are shortcuts you can use. And if you know how to use them, go ahead. In my experience, though, if people don't really know what they're doing and they try to use a shortcut, they mess it up and then they end up getting literally every problem wrong until we fix their calculator. So never change mu and sigma unless you know what you're doing. If you don't understand what I'm saying right now, never change mu and sigma. Okay, so we got a z-score. Now we need to work backwards. So here's our formula for z-score right here. That's the guy I'm looking for, the X. So if I solve that algebraically, I would multiply the sigma over, then add the mu. X is z sigma plus mu. I would memorize that. Definitely write it down. X is z sigma plus mu. So we're looking for that car that is 2.33 standard deviations above the mean. That's literally what a z-score means. That's what this 233 means. It means it's 2.33 standard deviations above the mean. So we just plug and chug. we get 34.5 miles per gallon. So what's that mean? Let's interpret that. A lot of times I'll ask students to interpret a percentile, and they'll just say, the 99th percentile was 34.5. And I'm going to take 2 points off for doing that. One, you didn't put units on, miles per gallon. Secondly, you don't interpret something by saying it is that. To interpret, I'm trying to think of a good English analogy. It's like you don't use a word to define itself. What does colloquial mean? Well, colloquial is defined to be colloquial. That's not a definition. Interpreting a percentile is not saying, oh, 34.5 is the 99th percentile. What's that mean? It means 99% of your population is below that. Or equivalently, 1% above. So the interpretation here is 99% of civics get less than 34.5 miles per gallon. Okay, next one, we're finding the 20th percentile. So I want this area down here to just be 20%, 0.2. So I can look at my picture and see that I'm looking for some car that gets much less than 31 miles per gallon. So I do inverse norm of this area down here that I shaded, 0.20. That spits out this negative z-score. That makes sense to me. It should be negative. It's below the mean. X equals z sigma plus mu. We get 30. So 20% of civics get less than 30 miles per gallon. Okay. These next one, we're going to find and interpret z-scores. Find and interpret. So interpreting is not, Dave's z-score is 2. So Dave had a 34 miles per gallon. That's above average. Remember, the average was 31. How far above average? Well, his z-score is 2. The one we're interested in minus the mean over the standard deviation. 2. 2 what? 2 standard deviations above the mean. That's the interpretation of a z-score. How many standard deviations you are either above if it's positive or below if it's negative. Okay, so Greg, his car gets 28 miles per gallon. His z-score is negative 2.29. What's it mean to be negative? Negative is below. By the way, when you write these out, don't say negative below. We say the word below because it's negative. I already took care of the negative by saying the word below. So his car is 2.29 standard deviations below the mean. Okay. And then the next question, here I'll scroll back up so you can see it, says, okay, let's find his percentile. So this is a different kind of percentile question. This is not a regular old percentile question. Because a regular percentile question, I tell you the percentage and ask you to find it, interpret it. Here we're going the other way. We know his gas mileage. What I'm asking is, what percent of cars get less than him? So we already got his z-score. Let's shade below him because that's what percentiles are. They're always shaded below. And we get 1%. So that's where Greg lives. He's 2.29 standard deviations below the mean. 1% of cars are even worse. They get lower gas mileage than him. Okay, practice these. You've got you got a couple of assignments coming up. this normal model assignment. I think you got two of those, an individual one and a group one. Think about your answers, write complete sentences, draw a picture on every single part. If you have any questions, feel free to send me an email. I will get, let's see, yeah, this is already turned in. I'll get this graded relatively soon, like today or tomorrow. All right, that should do it for this one.